Alright, so very good afternoon to all of you. I welcome you all on YouTube channel of Unacademy IIT JAM Live. This is your educator Srishti, and in this session we'll be discussing questions on atomic structure. We'll be first discussing questions on basic concepts of atomic structure. So before we start off with our session, first of all I would like to inform you some important points. So Unacademy is going to hike the prices very soon of your IIT JAM category. So if you want to take Unacademy plus subscription, you can definitely take it as soon as possible, and don't forget to use my referral code, that is SrishtiBLive10, for 10% discount on your Unacademy plus subscription. So if you want to beat these prices, if you want to beat this price hike, so Unacademy is also giving you one wonderful opportunity of free scholarship examination. So next examination is on 11th of April. The timings of this examination is 11 a.m. So the winners from each category or each subject will be eligible to get up to 100% scholarship on their plus subscription amount. Okay, so don't forget to join this test. Don't forget to just attempt this test, because definitely if you can get very good marks in this examination, you can get Unacademy plus subscription for free of cost. Okay, so without further ado, let's start with our session. So all of you, please let me know in the comment section if my voice is audible and it's clear, so that we can start off with today's session. Very good afternoon to all of you. Just let me know if my voice is clear so that we can start off with today's session. Very good afternoon, Manas, Subhanjali, Shubhra, Manish. So this is the new batches, right? So every week we are coming up with new batches. So this is batch 4th for biotechnology, batch 4th for physics, batch 5th for mathematics, and batch 5th for chemistry. So I'm a part of chemistry batch course as well as biotechnology batch course. So don't forget to use this referral code to get 10% discount on your plus subscription. Okay, so let's start off with today's session. Okay, so today we are going to discuss practice questions on atomic structures. This is a part 1 of our practice session. In this session we'll be taking fundamental concepts. Okay, we'll be discussing questions on fundamental concepts, and this particular session is highly important for IIT JAM biotechnology aspirants as well as IIT JAM chemistry aspirants. Okay, so let's take very first question in front of your screen. Before starting with the questions, I would like to request all of you to please give your 100% to each and every question. Okay, if you are not clear with the concept, feel free to ask me in the comment section, but in case you have studied the concept, then just give your 100% on each and every question. So let's take very first question in front of your screen. This is the first question, and the question is: Rutherford's experiment on scattering of alpha particles showed for the first time that the atom has option A, electrons, protons, nucleus, and neutrons. Is it coming now? Is it fine now? Sound is fine? Is it audible? Okay, it's audible, right? So the question is, okay, now it's fine. Okay, all right. So the question is, in Bohr series of lines of hydrogen spectrum, okay, you have Bohr series and you have hydrogen spectrum. Third line from red end, okay, third line from red end, to which one of the following inner orbital jump of electrons? Okay, so you have to tell the value of n final and n initial, and what all information is given to you, that it's a Bohr series of hydrogen spectrum, and you have to tell the n values for third line from red end. So this is the question. See everyone, how we can approach this question. First of all, what information should strike you after reading this question, okay? Alright, so I'm giving you a minute to solve this question. Okay, Manish A, Ambarish C. What about others? Yes everyone, what is the correct answer for this question? See, it's very simple how we can approach this question. First of all, what thing should strike you? What thing should strike you? What is red end, ma'am? Yes, that is what we are trying to discuss over here. The question is very simple and we have discussed each concept related with this question, okay? Just you need to join these dots, okay? See, how we can approach this question if it's written red end. If it's written red end, okay, so if it's written red end, so can I say this lies in visible region? Can I say this lies in visible region if it's written red end? Yes or no? Can I say this thing, this lies in visible region? Because red end means this is a color from Vibgyor, so this lies in visible region. Yes or no? Quickly everyone, just let me know in the comment section if this point is relatable, right? If it's written red end, that means this lies in visible region. All right, so very interesting question it is, right? So if it's from visible region, that means which spectra of hydrogen line? We know Lyman, okay, we have Balmer, then we have Paschen, okay, then we have Brackett, then we have Fund series, okay. So we know Lyman is in UV region, Balmer is in visible region. Yes or no? Yes everyone, Lyman is in UV region, Balmer is in visible region, okay. So that means we have to take Balmer series into consideration. Yes or no? Now it's making sense, right? The information is making sense. That means we need to consider Balmer series. Now quickly let me know in the comment section that what is n final value of Balmer series. Now just quickly let me know in the comment section what is n final value of Balmer series. What is n final value of Balmer series? Great. N final value is 2. Very good, Manish. N final value is 2. That means I have to tell third line from red end. Red end basically is telling you that it's a visible spectrum and we have to consider Balmer series. So red line, third line from red end. So if n final is equals to 2, so first line is going to be 3 to 2, second line 4 to 2, third line 5 to 2. Yes or no? Can I say option D is the correct answer? Yes or no? Everyone is clear with this concept? Can you relate with this concept? And the concepts are very clear that this is how we can approach this question. Yes or no? Is it clear, Ambarish, Akshay, Shubhra, Manish, and all of you those who are present in this session? All right. Very good. Okay, let's go to the next question then. This is your next question, and the next question is the increasing order lowest first for the values of E by M, that is charge by mass, for electron, proton, neutron and alpha particle. Come on everyone, very simple question. Just little bit calculations are involved, and right, more than calculations, just your conceptual level is involved. If you can relate the information conceptually, then definitely you can solve it. Okay, come on everyone, quickly give me your answers. We have a lot of questions to deal in this session. Okay, all right, so let's try and approach this question. Very simple question. We have to find out charge by mass ratio, that is E by M ratio or Q by M ratio. Okay, and this is given electrons. Okay, we have electrons, right? We have protons, we have neutrons, and we have alpha particle. Okay, so we have electrons, protons, neutrons and alpha particle. Okay, so first of all, just let me know what is charge of an electron. We know charge of an electron is 1.6 into 10 to the power minus 19 coulombs, but I have discussed that we have to take relative charges, so just to avoid our calculations. Okay, so can I say that if I consider charge of electron and proton, can I say one is charge of electron and one is charge of proton? Can I write this way? Yes or no? Can I write this way? One is charge of electron and one is charge of proton. Relative charges, that is 1.6 into 10 to the power minus 19. So I can write it for electron, I can write it for proton. Okay, we know neutrons are uncharged particles, they are neutral particles. Okay, so I can write zero charge for neutron. Okay, what is alpha? Alpha is helium nucleus, He2 positive. Alpha is helium nucleus, He2 positive. That means you have two protons in helium, two neutrons in helium. Okay, if you have two protons in helium, can I say 2 into 1 is charge of alpha particle, because neutrons are uncharged particles? Yes or no? Neutrons are uncharged particles. Then we have mass. Okay, then we have mass of electron. See, we know mass of electron is 9.1 into 10 to the power minus 31 kgs. Okay, we know mass of electron is 9.1 into 10 to the power minus 31 kgs. Okay, we know mass of proton is 1.6 into 10 to the power minus 27 kgs, and we know mass of neutron is approximately 1.6 into 10 to the power minus 27 kgs. Okay, so let's suppose what I'm doing, I'm writing mass of electron as Me, mass of proton as Mp, and mass of neutron, that is Mn, which is equals to Mp, that is mass of proton. Okay, so this way you can relate the values without using exact values. Okay, so mass of electron is Me, mass of proton is Mp, and mass of neutron is also Mp. Now what about alpha particles? Okay, we know alpha particles atomic number is 2, Z value is 2, and atomic mass value is 4. Alpha particle is helium 24. Okay, so atomic mass is 4 for alpha particles. Okay, if atomic mass is 4, so we got 2 protons plus 2 neutrons in alpha particle. Okay, so 2 protons plus 2 neutrons. Okay, and the mass of proton and mass of neutron is same. So can I say 4 into mass of proton is mass of alpha particle? Yes or no? Can I say 4 into mass of proton is mass of alpha particle? Can I write this way 4 Mp? Yes or no? Can I write this way 4 Mp? Right? Okay. All of you are clear with this part, how I have substituted 4 Mp over here. Okay, this is how we can do the calculations. It's 2 protons plus 2 neutrons. Since mass of proton and mass of neutron is similar, so we can substitute values over here. Okay, so what can I write now? Very simple. See, it's going to be 1 by Me, charge upon mass ratio, it's going to be 1 by Mp. It's going to be 0, because 0 upon Mp, it's going to be 2 by 4 Mp, right? So which is equals to 1 by 2 Mp, which is equals to 1 by 2 Mp. Okay, now we know mass of electron. See, this is 0 and this is 1 upon something, 1 upon something, 1 upon something. Okay, 0 will definitely come first. Okay, because all these three values will have some decimal points. Okay, so definitely we have neutrons, neutrons, neutrons. So I can cancel out option A. Right, next is C. Mass of electron is less than mass of proton. So we know that this ratio is going to be more than 1 by Mp ratio. Yes or no? If denominator is less, so overall value is going to increase. So 1 by Me value is more than 1 by Mp value. So definitely electron will come first. Electron will come first. We can cancel option B also. Yes or no? Right? We can cancel option B also. Great. Alright, let's go to the next thing now. So it's 1 by Mp and it's 1 by 2 Mp. Now denominator have increased. If denominator have increased, so the value is going to decrease. So we got alpha, then we have protons. Yes or no? Is it clear to all of you? Is it clear to all the biotechnology aspirants, those who are present in this session? Is it clear, Shubhra? Is it clear, Akshay? And if it's not clear, Manas, then please let me know. It's clear to all of you? Okay, great. So this is how we can express this particular question. Okay, I hope it's very much clear to all of you. Let's go to the next question. Yes, Deval, what is your doubt? Just let me know. Okay, Shubhra, see how we can how we can proceed with this question. Pay attention. See, we have we have to find out charge by mass ratio. Okay, we have to find out charge by mass ratio. Here I am writing electrons, here I am writing protons, here I am writing neutrons, and here I am writing alpha particles. Okay, now pay attention. We know that charge of neutron is 0. Okay, so 0 upon something will definitely the value is 0. Okay, next is alpha particle. What is alpha particle? Helium 24, or I can write down helium nucleus. Okay, what is now then charge of alpha particle? Charge of alpha particle is, in helium we have 2 neutrons and 2 protons, right? In helium we have 2 neutrons and 2 protons. Okay, if we have 2 neutrons and 2 protons, we know neutrons are uncharged particles, so the charge of helium is coming from number of protons. Okay, the charge of helium is coming from number of protons. Okay, so I can say we have 2 protons. Can I say we have two protons? Okay, so in alpha particles I have 2 protons and the charge is coming from 2 protons. Let's suppose the charge of electron is 1, because we know charge of electron is 1.6 into 10 to the power minus 19 coulombs, and charge of proton is also 1.6 into 10 to the power minus 19 coulombs. Okay, so we are taking a reference value of 1, since we know charge of electron and charge of proton is equal. Okay, so if the charge of electron is 1, because how we used to write down electron? -1. Charge of electron is -1 and charge of proton is 1. Okay, so charge of electron is 1, charge of proton is 1. Okay, right? So this is charge and charge. What about charge of alpha particles now? Since we got 2 protons over here, so charge is coming from protons. So charge of 1 proton is 1, so charge of 2 protons will be 2. Yes or no? Charge of 2 protons will be 2. Okay, divided by mass. Here we don't have to do anything, because 0 upon something will give you 0 value only, right? So divided by mass. Okay, now let's proceed and let's find out mass. Okay, so we know that mass of electron is 9.1 into 10 to the power minus 31 kgs. Okay, mass of proton is 1.6 into 10 to the power minus 27 kgs. Mass of neutron is 1.6 into 10 to the power minus 27 kgs. Okay, so can I say this thing, mass of proton is equals to mass of neutron? Can I say this thing, mass of proton is equals to mass of neutron? Okay, so I'll be writing mass of proton over here, right? And here we don't have to write because it's going to be 0, but let's write it mass of neutron. Okay, over here I'll be writing mass of electrons because the value is different. Okay, so I can write mass of proton or mass of neutron over here. Both values will give me same expression. Okay, next is, what is mass of a neutron? What is mass of a neutron? Okay, what is atomic mass of a nucleus? What is atomic mass, right? So see, in alpha particles, atomic mass is equals to 4. Atomic mass is equals to 4, right? Atomic mass of helium is 4. So atomic mass is nothing but summation of number of protons plus number of neutrons. Okay, and we know in alpha particle it is a helium nucleus, so we have 2 protons and 2 neutrons. Okay, so atomic mass is equals to 4. We know that mass of proton is equals to mass of neutron, so I can write we have basically 4 into mp. Yes or no? Right, so total mass is going to be 4 into mass of proton, because mass of neutron is equals to mass of proton. Yes or no? This step is clear, how the mass is 4 mp or 4 mn. This part is clear, how the mass is 4 into mass of 1 proton or 4 into mass of 1 neutron. First of all, tell me, this part is clear, how I am substituting 4 mp, right? Because atomic mass is 4. Okay, so I'm writing now, I am just substituting this value 4 mp over here. Okay, so final ratio, what is the final ratio that we got? 1 by me for electron, this is for electron, 1 by mp for proton, right? 0 value for neutron, and 2 by 4 mp, 1 by 2 mp, right? 2 and 2 will be cancelled out for alpha particle. Okay, Great. Now we have to arrange them in increasing order, right? So that means from least value, I have to arrange them, right, in increasing order. So this is 0 and 1 divided by something will give me decimal value, 0 point something something, but definitely that is going to be more than 0. Okay. So first of all, we are arranging them in E by M ratio, that is charge by mass ratio. So first of all, we'll be having nucleus. Then I got 1 by Me, 1 by MP, 1 by 2 MP. I know mass of electron is less than mass of proton. So if denominator is less, the value is going to increase, right? If denominator is less, the value is going to increase. So this denominator is less, okay? Mass of electron is less. So the mass of this particular total value 1 by Me will be highest value, okay? So this will be over here electron. Then I have 1 by MP and 1 by 2 MP. Since denominator is more, 2 into mass, 2 into some value, 2 into some value, right? So it's going to be more than this value. So this value will now, overall value will decrease because you have more amount in denominator, okay? So then we got alpha particles, then we have protons. So each and every step is clear. Last step is clear, how I have arranged them in, right, increasing order. Okay, see, you can ask questions, right, 10 times, okay? It's not a big problem, okay? But please make sure before ending a particular session your doubts should be clear, okay? So that we don't have to, right, again and again discuss the points after completion of a particular topic. Okay, great. So the correct answer for this question is option E. All right, so I hope this point is clear to all of you. Great. Let's go to the next question now. Okay, so this is the next question. Okay, yeah, this is the next question. Okay, let's take some different question. We'll be coming back to this question. Yeah, so this is the next question. See, this is a MSQ question. More than one answer can be a correct option, right? So it's a MSQ question. Alright, let's try and approach this question now. See how we can approach this question. the energy of an electron in the first Bohr orbit, that means n is equals to 1. Okay, so energy of an electron in first Bohr orbit of hydrogen atom, that is Z is equals to 1. Okay, this value is minus 13.6 electron volt. The possible energy values of the excited states for electrons in Bohr's orbit of hydrogen atom. What is the formula of energy, everyone? Energy is equals to minus 13.6 Z square n square electron volt per atom. Okay, this is the energy. So we know n value is equals to 1 and Z value is equals to 1, and in that case the energy is minus 13.6. So we need to find out the possible values for excited state. Okay, so excited state means I have to put n is equals to 3, n is equals to 4 and so on, and I have to verify that which of the given options can be your possible energies. Okay, so n is equals to 2, n is equals to 3. Okay, so Z is always 1 because it's a hydrogen atom, so Z is always 1. Okay, so we need not have to consider Z. So now what is the energy expression? Energy expression is minus 13.6 1 by n square, right, electron volt per atom. So when n value is equals to 1, energy is already given in the question, that is minus 13.6. So what can I say when n value is equals to 2? Energy is going to be minus 13.6 divided by n square, right? N is 2, so it's going to be 4. Yes or no? Right, this is one possible energy. Then energy is equals to n is equals to 3. So what value is going to be minus 13.6 divided by 9. Yes or no? This is how we can solve the problem, right? Okay, now let's see how we can substitute the values in scientific calculators and we can find out the value. Okay, so now we should know how we can use the scientific calculator so that we can save our time in examination. Okay, so this is 13.6 divided by 4. See how we can just find out the value. We can find this value with normal calculators also, but it's very beneficial for us to use scientific calculators. Okay, so it's going to be minus 13.6. See, minus 13.6 divided by 4. Okay, so the value is 3.4. Okay, so we can write this value is minus 3.4. Yes or no? So next value is 13.6 divided by 9. Okay, so how we can solve this particular value? See, minus 13.6 divided by 9, right? So it's going to be 1.5. Okay, this way you can improve your this way you can improve your skills of using calculators also. So it's going to be minus 1.5. Okay, so this way, right, you can solve this particular question. Okay, I hope this is very much clear, right? And now the correct answer is going to be, now you guys tell me what is going to be correct answer. 3.5 we have already calculated, 3.4 is the correct answer, 1.5. Okay, see, it's very important. When n is equals to 2 we are getting minus 3.4, when n is equals to 3 we are getting minus 1.5. so now the n value is going to increase and the energy value will be decreasing. Okay, it's going from minus 3.4 to minus 1.2. that means the energy value is going to decrease in positive terms. Okay, so definitely this cannot be a correct answer, this cannot be a correct answer. So just by using n is equals to 2 and n is equals to 3 you can find out the correct answer, and there is no need to even substitute n is equals to 3. Okay, n is equals to 4. Okay, so the correct answer is going to be option A and D. Okay, I hope it's very much clear to all of you. No, Akshay, it's like mixed questions from various national entrance examinations. Okay, so that you have proper knowledge of the concept. So these are mixed questions from various national examinations. Okay, so I hope this much is very clear to all of you. Now let's go to the next question. Any doubts in this question, you can ask me. Yeah, again a very simple question. With increasing principal quantum number, the energy difference between adjacent energy levels in each atom. We have discussed this thing very clearly in the special classes also. With increasing principal quantum number, the energy difference between adjacent energy levels in each atom increases, decreases, remains constant, decreases for low value of Z and increases for high value of Z. Come on everyone, just shoot up your answers very quickly. Very easy concept. What will happen if quantum number is increasing, n value is increasing? So what's going to happen, right, in delta E value? Decreases, increases, remains constant, decreases for low value of z and increases for higher value of z. Okay, pay attention everyone. We have discussed this thing. We have different energy levels. First of all, what you need to discuss, what you need to consider is, read question very carefully. With increasing principal quantum number, the energy difference between adjacent energy levels in H atom, when it is written hydrogen atom, so Z value is equals to 1 always. Yes or no? So how D can be the correct answer? Decreases for low value of Z and increases for high value of Z. Z will remain constant. It's given hydrogen atom. Yes, Akshay? Is this point clear? That it's given hydrogen atom. So Z value will remain constant. Right? You don't have to check Z value because it's going to remain constant. Right? It's written in the question that this is H atom. Right? So can you identify your mistake? D is not the correct answer because it's written in the question that it is hydrogen atom. When it is hydrogen atom, so Z value is always 1. Okay, great. So see, next thing what we are going to see over here is energy is minus 13.6, Z square, Z is 1, so 1 by n square. Okay, so now what you need to consider, we just saw this thing in previous question that for first energy level value was coming 13.6, for second energy level value is coming 3.4, for third energy level value is coming 1.5. Yes or no? These are the energies which we calculated. Okay, I'll tell you. Okay, first of all, just consider this question. These are the things which we can write. We have calculated in the previous question. So just calculate this difference and tell me what is the difference coming. Just calculate this difference and tell me what is the difference coming. Approximately this will be equals to 10 point something. Yes or no? The difference is going to be 10 units approximately, right? And over here you can see the difference is going to be 1.5 units. Yes or no? So with increasing value of n, the energy gap between consecutive energy level decreases. Yes or no? And we have discussed this thing in the session also, that when n value is increasing, that means there's going to be a point when discrete levels will get vanished, and in place of discrete levels will be getting continuum. That is classical theory. Okay, at higher values of n will be getting continuum. So that is how we are getting continuum, because energy level decreases, spacing between two energy level decreases. Okay, and if spacing between two energy level decreases, so there's going to be a point when we are going to achieve a continuum. Okay, there's going to be no discrete energy levels. Okay, so the correct answer for this question is option A, decreases, right? Okay, so when it will be valid, basically see, energy depends on your n value. Okay, energy depends on your n value. Definitely you will be asking that energy is equals to minus 13.6 Z square by n square. So with increase in Z value, energy is going to increase, but that is a true statement for each and every Z value. That means when Z value is going to increase, the energy will be increased when n value is constant. If you are changing n value also, if you're changing Z value also, so it's not very easy for us to compare the energy values, right? So we need to take one thing constant and then we can alter the second thing. Okay, so if n value is constant, then we can say with increase in Z value, energy is going to increase, and with decrease in Z value, energy is going to decrease when n is constant. Okay, if n is not constant, so we cannot relate this with your z value. And if you're finding the relation with n value, so what we can say, keeping z constant, that is it's for hydrogen atom or for Li2 plus atom or for beryllium 3 plus ion, when n value is increasing, energy is going to decrease. Yes, so you have to be calm for the questions, okay? Each and every question in your examination is going to be very simple, and definitely it will come from the concepts which we have already discussed in the sessions, okay? Just you have to keep revising your concepts and you have to apply those concepts in questions, okay? So I hope this point is now clear to all of you. Any doubts in this question? If you have any single doubt in the question, or any right thing is not striking, the concept is not getting, let me know in the comment section. Okay, great. Let's go to the next question. Don't freak out just by seeing the calculations of the question. It's very simple. We did this thing many times. You just have to apply that same knowledge which we have used in our sessions. Okay, so just see what information you have to find out, how you can find out, and how you can substitute. You know what is A naught, you know what is H, how you can get this relationship, you know what is the relationship of kinetic energy. Okay, just try to rearrange the things and you'll get the answer. Yes, everyone. So, can you find the correct answer? Have you got the answer for this question? Okay, let's try and approach this question very simple. Just we need to rearrange the things, okay? So the question is the kinetic energy of an electron in the second Bohr orbit of a hydrogen atom, okay? What we need to find out, we need to find out the kinetic energy of an electron in the second Bohr orbit. So can I say n value is 2? Quickly tell me in the comment section. Can I say n value is 2? Right, because it's second Bohr orbit, that means stationary state orbit or shell's value is 2, okay, of a hydrogen atom. So can I say z value is 1? Yes or no? Can I get these two things from the question? Okay, great. Next is I need to find out the kinetic energy, okay? So n value is equals to 2 and z value is equals to 1. Can I say kinetic energy is half mv square? Yes or no? Can I say kinetic energy is half mv square? Right? So if kinetic energy is half mv square, so somehow I have to substitute the values of velocity in this question to get these terms, okay? So how I can proceed now? See, I know this thing very clearly from Bohr's postulate that mvr is equals to nh by 2 pi. Yes or no? Angular momentum of electrons are quantized. mvr is equals to nh by 2 pi, okay? So this is the angular momentum of this electron. We have this address of electron, it is present in second Bohr orbit and it is of hydrogen atom. So can I substitute n value is equals to 2 over here, and can I find out the value of angular momentum for this electron? Definitely I can find out the value. So it's going to be mvr is equals to n, in place of n I can place 2 h by 2 pi. Yes or no? 2 and 2 will be cancelled out, it's going to be h by pi. So can I say mvr is equals to h by pi? Yes or no? Now I have this velocity in expression of kinetic energy, so I'll find out this value of velocity from here, that is going to be h mr pi. Yes or no? Is this point clear to all of you? Velocity is equals to h mr pi, right? Okay, now I'm substituting this velocity over here, that is half m, it's v square, so it's going to be h square m square r square pi square is equals to kinetic energy. Yes or no? This is how I can find out the value of kinetic energy. Now let's go back to the options, and then in the options you can see that this is this this particular variable written over here, this particular constant written over here, that is a naught, and we know a naught is a Bohr's radius, it's a Bohr's radius, okay? So a naught is a Bohr's radius, so somehow I have to write, just get the value of Bohr's radius, okay? So I have to just rearrange this equation and somehow I have to get the value of Bohr's radius. That means now in this particular expression you can see I have this radius value, so somehow I have to get this value of radius, okay? So how I can get this value of radius? Pay attention everyone, now it's going to be very interesting. We have to find out value of radius, okay? So this is mvr, which is equals to nh by 2 pi, okay? So mvr is equals to nh by 2 pi, okay? So what is your Bohr's radius? We need to find out a naught value. So we know kze square by r square is equals to mv square by r. Yes or no? Inward force is equals to outward force. This is how we have derived various equations in Bohr's postulate. Yes or no? Right, this is how we have derived various equations in Bohr's postulate, right? So what can I write over here? That kze square r is equals to mv square by r, right? This r will be cancelled out, okay? This is how I can write this thing. Yes or no? First of all, tell me this part is clear to all of you or not? Clear or not? Great. Okay, so now what can I find out from here? So I have substituted the value of velocity over here, so now I'm getting radius over here. I have to just substitute the value of radius over here. Okay, and how I can substitute the value of radius? I need to find out the value of r. Okay, so now what is the value of r? How I can find out the value of r? See, it's very simple. We know this thing now, that k z e square r is equals to mv square. Okay, so I have to find out the value of r, so I'll be using this expression again. mvr is equals to nh by 2 pi, and this n is equals to 2, so mvr is equals to h by 2 pi. Okay, so I have to get the value of r, so velocity is h by mr pi. Okay, so I'll be substituting velocity again over here. So it's going to be kz e square by r is equals to m, right, h square m square r square pi square. Okay, this is how I can substitute the value. So this r and r, this will be cancel out. Okay, it's going to be kz e square, this r will be cancel out, one m will be cancel out, h square. Okay, this is 1 m over here, this is 1 r, and this is pi square. Okay, this is how we can find out. Now I have to take this value r over here and keep constant in one places. So h square is a constant, m is a constant, pi square is a constant, k is a constant, z value is 1 because this is for hydrogen atom, e square is a constant. So this is your Bohr's radius, yes or no? This is the value of r for this expression. Right? Okay, now just I need to substitute the value over here. So it's going to be 1 by half m h square m square, r value over here is r4, right? Basically it's going to be m4 and it's going to be h square, then we have pi 4, then k square e4. Okay, this is how I can substitute the values over here. Now we can see over here that this particular value is a naught. Okay, this value is a naught, so I can say that the correct answer for this question is option C. Clear or not? Is this point clear to all of you? Great. Okay, so what are your doubts in this question? I am seeing a lot of questions. 1 second. No, see over here k is your constant. Okay, the Coulomb's constant 1 by 4. Okay, what I'll do, I'll just I'll just give you the answer for this question in a written format in group. Okay, after this class I'll write each and every step and I'll send the solution to you. Okay, that way you can understand it from the steps. Okay, might be it's not clear right now, but if I'll send you step by step solution so you can understand the question. Okay, I'll be sending the solution to you after this class. Okay, so let's go to the next question and let's take this next question. Okay, see, I can see a lot of doubts in the previous question. Okay, wait a second, we'll solve it. Okay, no issues, we won't leave any doubt. I won't leave any doubt from my end. Let's solve this question. Now pay attention everyone. See, okay, let's go with short way. Okay, that way you can understand this question more easily. Okay, now just pay attention and see what we have to do in this question. See, pay attention now. We have to find out kinetic energy, and kinetic energy formula is half mv square. Just let me know step by step if the step is clear. Okay, kinetic energy formula is half mv square. Okay, we know that angular momentum of an electron is mvr is equals to nh by 2 pi. Yes or no? We know angular momentum of an electron is mvr is equals to nh by 2 pi. Since it's given, the address of electron is given in the question, that n is equals to 2 and z is equals to 1. Okay, since the address of electron is already given in the question, n is equals to 2, z is equals to 1. So I can substitute the value of n is equals to 2 over here. So mvr is equals to 2h by 2 pi. Okay, mvr is equals to 2h by 2 pi. So 2 and 2 will be cancelled out. So mvr is equals to h by pi. Okay, let's go with short way. Let's go with simple way so that you can understand this question. This step is clear. mvr is equals to h by 2 pi. So I got this velocity over here. So velocity is equals to h by pi mr. Right, velocity is equals to h by pi mr. Now I'll be substituting this velocity in this kinetic energy formula. So kinetic energy is going to be half m velocity square. So this, right, h by pi mr whole square, it's going to be half mass h square pi square mass square r square. This much is clear to all of you. Any doubts in this step? This step is clear to all of you, how we got to this step. Okay, great. So now next thing is, what is the final formula? This one mass and this one mass will be cancelled out. Okay, this one mass and this one mass will be cancelled out. So kinetic energy is equals to, right, we are left with h square 2 pi square m r square. Yes or no? Right, we are left with this expression of kinetic energy. Okay, great. Now in the expression we have h square. Okay, we got our h square in the expression, right? We have pi square, but we have the expression in terms of a naught, that is Bohr's radius. Okay, so I know this expression of radius, that radius is equals to a 0.529, right? Radius is equals to 0.529 n square by z. Yes or no? This is the formula of radius. Yes, everyone, just let me know if you are clear with this formula. 0.529 n square by z. Yes or no? This is the formula. Okay, great. So can I say that this 0.529 is a naught, that is your Bohr's radius? Can I say this thing, this 5.29 is a naught, that is Bohr's radius? So our formula is basically Rn is equals to a naught into n square by z. Right, this is our radius formula, and the kinetic energy formula that we got is h square 2 pi square m r square. Yes or no? Yes, this is the formula that we got, and this is the radius. Okay, since we know this question is for hydrogen atom, so z value is equals to 1, and this is for second Bohr's orbit, so n value is equals to 2. So radius for this question is 4a naught. Yes or no? This step is clear. Okay, all right. So substitute this value over here. You will be getting h square 2 pi square m 4a naught whole square. So it's going to be h square 2 pi square m 16a naught square. 16 into 2, that is 32. So h square 32 pi square m a naught square. H square 32 pi square m a naught square. Yes or no? Now it's clear. Any doubts in this question? Any doubts in this question that is not clear? All right, okay, if you have any doubts, just let me know. Let's go to the next question. Okay, I'll send. See, that was the way which seems to be little lengthy, but you can solve from that way also. If you want to look the answer from that, if you want to know the other perspective of this question also, so I'll send that question in the group. Okay, I'll send the solution from that way also in the group, so that you can understand what actually I did in that particular derivation. Come on everyone, quickly tell me the answer for this question. The question is, radius of which of the following orbit is same as that of the first Bohr's orbit of hydrogen atom? See, very simple how we can approach this question. What is radius? Radius is Rn is equals to 0.529. Just now we discussed. No issues, Akshay. I'm here for your clarity only, right? So basically, see, this is for the first time. Okay, to be very honest, this is for the first time I'm taking courses for biotechnology. Okay, so basically I'm taking some time to understand that how I have to put the concepts in front of you. Okay, so with each passing class, with each passing day, right, I'm learning new things also, that how I have to put the concepts. Okay, so maybe it's a possibility that, right, I'll put the concept in like some complicated way or in some lengthy way. Okay, and right, definitely there are more possibilities also, so I'm just learning with each day that how I can put concepts in front of you. Okay, so, but definitely if you want to learn other perspectives also, if you want to learn new things also, so I'm always available to you. Okay, you can ask me anything, you can ask any of your doubts, right? And definitely I'm trying my level best to present each and everything in a simplified manner. Okay, great. So this is Rn 0.59, which is n square by z. Okay, so the question is, the radius of which of the following orbit is same as that of first Bohr's orbit of hydrogen atom? So for hydrogen atom, z value is equals to 1 and n value is equals to 1. So radius for first orbit of hydrogen atom is 0.529, because n value is 1 and z value is 1. Okay, so radius of first orbit is 0.529. So you have to arrange these two values somehow, so that you'll be getting radius is equals to 0.529 as that of your Bohr's orbit. Okay, so if this value, the numerator value, and if the denominator value will be equal, so you'll be getting radius is equals to 0.529. So somehow you have to arrange these two values so that you can get the radius is equals to 0.529. Okay, so we know this thing very clearly, that if n value is equals to 2, n square is going to be 4, right? And the atomic number for beryllium is also 4. So 4 and 4 will be cancelled out and you'll be getting radius as 0.529. But let's verify this thing with all the options so that we can have better clarity and we can revise our concepts. For lithium, n square is definitely 4. Okay, and for lithium, what is atomic number? 3. So this value is not equals to 1. Okay, so this is our incorrect option. Let's go to Li2 plus in. N value is equals to 3, so 3 square is going to be 9, and for this Li is it's 3, Z value is 3, so this is 3, this is not 1, so we can cancel out this option also. For He2 plus helium, right, for helium plus N is equals to 2, so N square is 4 and this value is 2, so again it's 2, it's not coming 1, so that is only possible when option D is going to be your correct answer. Okay, that is only possible when option D is going to be correct answer. Okay, only option D is your correct answer. Is this point clear to you? Any doubts? Shubhra, is this question clear? You're facing any problems? Just let me know. No problem. Okay, so I hope my way I hope my way of explaining the concepts is like simple, it's not very complicated for you. If in case you feel like I'm explaining in complicated way and you want more simplified way, so you can always let me know. Okay, all right, so this is the way we can solve this question. If in case you have any doubts in this question, just let me know. Great, all right. Okay, let's go to the next question, everyone. Very simple question. I want answer for this question in fraction of seconds. The spectrum of He positive is expected to be similar to that of hydrogen, Li plus Na, helium. Very simple question. I want answer in fraction of seconds. The spectrum of He positive is expected to be similar to that of hydrogen, Li plus, sodium, helium. Okay, Akshay, just do one thing. You just again message me after this class. Okay, maybe right, your message is lost. Okay, you just message me again so that I can see your question and I'll message today for sure. Okay, just remind me once, just message me again. Yeah, very good. The correct answer is going to be hydrogen without any doubts. Okay, try this question again. It's a very simple question. Bohr model can explain option A, the spectrum of hydrogen atom only, option B, spectrum of an atom or ion containing one electron only, option C, the spectrum of hydrogen molecule, option D, the solar system or the solar spectrum. Yes, very good. So correct answer for this question is option B, spectrum of an atom or ion containing one electron system. Basically, Bohr model was able to explain spectrum of any atom or ion which is having only one electron. So it is applicable for monoelectronic species. Okay, very good. The correct answer for this question is going to be option B. Great. Let's go to the next question. The ratio of the energy of a photon of 2000 angstrom wavelength radiation to that of 4000 angstrom radiation is. Again a simple question, simple formula, simple substitutions, and you can find out the answer. Solar spectrum, Rakesh, is actually, it's an example of absorption spectrum. Okay, solar spectrum is an example of absorption spectrum. Okay, so in this particular case, basically we get, right, number of dark lines, the number of dark lines are absorbed, the number of dark absorption lines. Okay, we discussed this thing in the session also, that we have two types of spectrum, absorption and this emission spectrum. Absorption spectrum is an example of dark lines, right, dark lines on color background, right, and emission spectrum was an example of color lines on dark background. Okay, so this solar spectrum, it's an example of absorption spectrum where we are getting dark lines on color background. Okay, let's try and find out how we can solve this particular question. See, it's very simple. We need to find out the ratio of energy of a photon So we got two photons and we need to find out ratio of their energy. That means energy of one photon divided by energy of second photon. This is what we need to find out. We know this thing very clearly, that E is equals to hc by lambda. Okay, since h is a constant value, that is 6.6 into 10 to the power minus 34 joules second, and speed of light is also constant, so both of these values are constant. Okay, so can I say this thing, energy is inversely proportional to wavelength? Yes or no? Can I say this thing, energy is inversely proportional to wavelength? If that is the case, so E1, right, by E2 is nothing but 1 by lambda 1 divided by 1 by lambda 2, or I can write down lambda 2 by lambda 1. Yes or no? So E1 divided by E2 is lambda 2 by lambda 1. So just I need to substitute the respective lambda value and I can get the correct answer. So lambda 2 is 4000 angstrom, 4000 angstrom. Lambda 1 is 2000 angstrom. Angstrom and angstrom will be cancelled out, right? 4000, 3 zeros, 3 zeros. It's going to be option D. Yes or no? Clear, everybody? Any doubts in this question? Great. Next question, again it's very simple. The question is, according to Bohr's theory, the angular momentum of an electron in the fifth orbit is. According to Bohr's theory, the angular momentum of an electron in the fifth orbit. Very good, all of you. Very good, Rakesh. Very good, Ambarish. Very good, Akshay. Very good, Shubhra. So this question is very simple, and we know how we can find out the angular momentum of an electron by the formula mvr is equals to nh by 2 pi. So we know angular momentum of an electron is quantized according to Bohr's postulate. So mvr is equals to nh by 2 pi. This is your angular momentum. Okay, so nh by 2 2 pi. Just we need to substitute the value of n, fifth orbit, so n value is equals to 5. So 5h by 2 pi, 5 divided by 2, 2.5. 2.5 h by pi. Clear? Great. Okay, so this is the next question, and yeah, this is the next question. It's simple, but at the same time it's totally conceptual question. Okay, there is no calculations, there is no theory related over here. It's totally conceptual questions. Just read question carefully and see what exactly the question is looking for. Okay, and you can definitely answer the question. All right, very right, simple question. Which electronic level would allow the hydrogen atom to absorb a photon but not emit a photon? Very simple and interesting question. For absorption of photon, the electron should be, right, it should be present in lower energy level, and by absorbing the energy it will go to higher energy level. Okay, so that means there should be availability of higher energy levels for absorption. Okay, for absorption there should be availability of higher energy levels. For emission, right, you should have at least one energy level present. You need to emit the electron, that means you have to release the energy, so at least you should be having one lower energy level, then that particular light will be emitting a photon. Okay, so we know that we have infinite energy levels. Okay, we have just completed our 50% of atomic structure. That is the theory part, okay, the postulate part. From the next session we have to start with quantum mechanical approach. That means this configuration electronic part and this orbital part, okay, the quantum mechanical approach. So we'll be understanding in that part that we have infinite energy levels in our atom. Okay, so if we have infinite energy levels, then definitely absorption is possible for every address, right, for every electron present in any orbital. Absorption is possible if it's present above, right, the nucleus. Okay, if it's present right above 1s, because we know in first level we have only 1s, so emission is also possible, emission is also possible, emission is also possible. But in option D, absorption is possible because it's present in 1s. But what about emission? For emission you should be having low lying energy orbital, and that is not present because 1s is the starting energy level. Okay, so the correct answer for this question is option D. Okay, so the correct answer for this question is option D. I hope this point is clear to all of you. Okay, great. Yeah, try this question now. All right. Very good, Rakesh. Very good, Shubhra. This is very right. This is actually simple question, because if you have revised the concepts that we have discussed in this session, so this question is right simple for you. You just need to arrange the things. So the question is, a stream of electrons from a heated filament was passed between two charges, plates kept at a potential difference of V ESU. Right? ESU is nothing, it's a unit of potential. Okay, electrostatic unit. Okay, electrostatic unit. So this ESU is nothing, it's a unit of your potential. Okay, so if you have two charged right species, if you have two charged particles, and they are kept basically at a potential difference of V. If E and M are charge and mass of an electron respectively, then the value of h by lambda. You need to find out the value of h by lambda. Okay, so we know this thing very clearly, that what we need to do, that we know this thing very clearly, that lambda, which is your de Broglie wavelength, is h by mv. Yes or no? We know this thing very clearly, that lambda, which is your de Broglie wavelength, is h by mv. We need to find out the value of h by lambda. So I am taking this mv over here. So we need to find out this value of h by lambda. Okay, so this is our first equation, that h by lambda is mv. We know this thing very clearly, right? We have discussed this thing, that whenever I need to give motion to a particular charged particle, so how I can explain this thing, that particular motion that is represented by kinetic energy is charge into V, right? Is charge into V. We have discussed this thing in this session. Kinetic energy of that particle, the motion of that particle, is charge into V. Okay, and over here that particle is electron. So can I say that this Q is E? Yes or no? Can I say this Q is E? So kinetic energy is EV, yes or no? First of all, tell me this point is clear. Kinetic energy is EV. Then I'll move to the next step. Before that, you tell me if this step is clear or not. Clear? All right. So kinetic energy is equals to EV. Okay, what is kinetic energy actually? Half mv square. Kinetic energy is half mv square is equals to EV, right? And what we need to find out? We need to find out value of mv. Yes or no? We need to find out value of mv. So again, what I'm doing, I'm dividing this with mass and multiplying this with mass, so as to get the value of mv. So I'm dividing this with mass, multiplying this by mass. Okay, so I'm just continuing over here. Okay, so this is half mv whole square divided by m is equals to ev. This step is again clear to all of you? Yes or no? Okay, so this is mv and this is your h by lambda. That is what we need to find out. So if I can find out the value of mv, that value is going to be h by lambda value only. Okay, so I'll be taking this mass over here and this 2 over here. So mv whole square is equals to 2 mev, right? And I need to find out this value of mv, so I'll be taking under root over here. So under root of 2 mev, so this value is equal to mv. So h by lambda, which is equals to mv, this is equals to 2 mev. Yes or no? Yes or no, everyone? Clear or not? Clear? How many of you are present in this session? Who all are present in this session? Rakesh, Shubhra, Akshay, those who are present in this session, just let me know if this question is clear or not. Okay, clear. So let's see that how many questions we have already discussed. Rest of the questions I'll give you in homework, and we'll discuss the questions in the next session. Okay, so we have discussed this question, Okay, I'll send the pdf in the Telegram channel. Okay, I'm just giving you link of Telegram channel. If in case anyone is not enrolled in that channel, you can join that channel. I'll send the PDF of these questions in that channel. Okay, so this is the link of the channel. You can subscribe this channel and you'll be getting this PDF in that channel. Okay, and you can see we have discussed this question, we have discussed this, is also we have discussed, this is left, this is your homework question. Okay, and this is we have discussed, this is your homework question. Okay, and this is also your homework question. Okay, so we have discussed a lot of questions, and right, a lot more is given in this slide. Okay, so you can solve these questions, and in case you find any difficulty, so I'll arrange a special class and we'll discuss rest of the questions in that session. Okay, so this is my referral code. If any one of you are planning to take Unacademy subscription, the prices of the subscription, they are going to hike very soon, so you can take the Unacademy Plus subscription, and don't forget to use this referral code, that is Srishti B Life 10 for your subscription. I'll see you in the next class. I hope you found this session useful, right? And I'll keep coming with this practice sessions in upcoming classes.